Okay, so here we are. Oh, sorry. Good afternoon. I think it's afternoon. Yep, it's afternoon. Those of you who did your assignment, that was great. I really appreciate that. Most of you did really well on the getting ready for linear programming problems. So I want to do some really simple linear programming problems today. And unfortunately, I didn't really print them in a two-column format, which I should have done. But we'll manage it. So linear programming problems are a little tricky unless you really follow along with the method that I'm suggesting here, which is to make yourself a nice little table to organize all the information. And once you have the table done, then you can make the graphs. Once you got the graphs, then you can just do the stuff you did from the homework yesterday, 2 days ago, whatever. Just plug in the points into the equation. It's easy, but excuse me, you must make the chart first. Okay. So oftentimes when we want to find out what goes into a chart or what kind of is the most important stuff in a problem, sometimes we just really need to go right to the end of the problem and find out what it is we're being asked to find out. So let's go and do that right now. So I'm going to read the last sentence in the problem here. And by the way, here, so Bob is organizing a co-ed soccer team, and he wants to know how many people should be on the, well, I just gave it away. Anyway, how many men and women should Bob have on his team to maximize his score? So that's what we're really looking for. We're looking for the number of men and number of women on the team. So let's get some context here, and then we'll start to put it all together into a nice little box. So Bob is organizing a co-ed soccer team. There are a maximum of 7 people on the field. There must be at least 2 women and 3 men on each team. Women score an average of 4 points per game, and men score an average of 2. How many men and women should Bob have on his team to maximize his score? Okay, so the most important thing for us to consider here is that there are the things that we're looking for, which in this case is the number of women and the number of men on the team. I think that's the way I put it. That's the order I put it in, right? 7 people. There must be at least 2. Yeah, good. So women are first, men are second, and that's the order I put them in here. Not that it really matters. It just helps to organize the problem a little bit easier. And as you might imagine, since we're going to be graphing, we need an x and a y. So we don't need to put them in parentheses. That was just a little extra stuff that I'm doing here. So this is what we are looking to find. So what we're looking to find goes along the top of our chart. Along the side of our chart here go the limitations. Or the restrictions. So the restrictions are, or the limitations are, the things that prevent Bob, in this case, from having as many people on his soccer team as he wants. So let's figure out what the restrictions are, what prevents Bob from having as many people on his team that he wants of any kind. So it says that Bob is organizing a team. There are a maximum of 7 people on the field. So that's one of the restrictions right there. The maximum number of people on the field. It looks like may, but it's really max. And what else is there? What other limitations are there? Now that's what it says here. There are a maximum of 7 people on the field. He can't have 10 or 12. This is as many as he can have. So there must be at least 2 women. All right. Again, so here's another restriction. We can't have 17 women. We can't have 1 woman. We have to have at least 2. So women are one of our restrictions. And by the same token, we can't have 100 men on the team or 0 men on the team. We have to have at least 3. So that is another restriction. And so as we read through the rest of the problem here, there are no other restrictions that are preventing Bob from having as many people on the team as he wants. Okay, so now we need to do something with these restrictions here. So let's work with the second two, and then we'll do the first one. So it says here that there must be at least 2 women on the team. Okay, so women are being represented by X, and that's what's going on right here. So the number of women, X, has to be at least greater than or equal to 2. That's what it says, at least 2 women. And by the same token here, we have the number of men has to be at least 3. Men are being represented by Y, and we have Y greater than or equal to 3. So far, I hope this is all pretty straightforward and understandable. All right, so it also says that the maximum number of people on the team is 7. So we can put a 7 there, but it has to be less than or equal to 7 because we can't have more than 7. We could have fewer, like they could play with 5 people on the field if they wanted to. Not going to be very helpful, but they could do that. So, so if there are 7 people on the team, how do we figure out how many people are on the team? Well, we know the team is made up of men and women. I'm sorry, women and men. So the number of women on the team on the field at the moment is X, and the number of men is Y. And so we're going to end up with a little equation here, an inequality. X plus Y is less than or equal to 7. So we're going to write out our inequalities here, and then we're going to graph them. So I'm going to write them over here. So we're going to have, actually if I write them down here, I'll be able to keep it all in the screen. So we're going to have X plus Y is less than or equal to 7. We're going to have X is greater than or equal to 2, and Y is greater than or equal to 3. Now you can graph all these 3 i's by hand, and that's fine. You did that yesterday or 2 days ago. Or you could graph them on Desmos, and you can graph them just like this on Desmos. But what you're going to find, and I'm just going to draw it up here because it's not really necessary to see this, is we're going to make some sort of triangle right here. And but you're going to see that we're going to have some shading for blue, which is going to go this way, which is going to be to the right over here. We got some blue over here. And then we got some green, where we're going to shade up here. Right, we're going to shade up here. This is green. We're going to shade above that line. And all this green in here. And then we got some red, and red is going to be below this thing right here, below the diagonal line. And so you can see there's just way too much color and crap in here, and this is just really hard to see what's going on. So as it turns out, if you actually flip all the inequality signs, the shading is going to be actually outside of the triangle, and it's going to leave a nice, clean, white triangle right in the middle, no coloring. It's going to be easy to see. So when you put these guys into Desmos, just flip them. X plus Y is greater than, and you can just do greater than. You don't need to do the equal part because you'll get the same thing. So X plus Y is greater than 7, X is less than 2, Y is less than 3, and you get your nice triangle. So as it turns out, I've already graphed these things on Desmos for us. So there's what the triangle looks like. We have these key points right here, 3, 4, 3, 2, and 5, 2. So we found our points, which are 3, 4, 3, 2, and 5, 2, I think is what we found. Yep, 3, 4, 3, 2, and 5, 2. Okay, great. So these are the ordered pairs. Now you remember that we need to have something to put the ordered pairs in because we want to maximize something. Well, what Bob wants to maximize is he wants to maximize the score. And let's find out if we can find a sentence that involves the word score. So women score, there it is. Women score an average of 4 points per game, and men score an average of 2. So what we need to do is we need to write an equation that represents that situation. So it says women score 4, men score 2. So the total points equal to 4 times the number of women on the team, and the number of women is represented by X, plus 2 times the number of men, which in this case is represented by Y. So we have our ordered pairs 3, 4. And so now we just do what we did in the homework assignment. Take 3 and put it in for X, 4 and put it in for Y. So we got 4 times 3 plus 2 times 4 makes 20. And here we have 4 times 3 plus 2 times 2 makes, that's supposed to be a 3. 12 plus 4 makes 16. And here we have 4 times 5 plus 2 times 2 makes 24. So in order to maximize the score, Bob should have 5 women, 2 men. That will maximize the score. Okay, so let's go through the process again. Step 1, figure out what it is that we need to find out. And that's generally right at the end of the problem. How many men and women should Bob have? That goes right there. And then figure out what the restrictions are. What is it that prevents Bob from having as many people of whichever gender he wants on the team? And so what is it prevents that? Or as many people as he wants and whatever gender he wants. And so there are restrictions here. We have the maximum number of people on the team is 7. There have to be at least 2 women. There have to be at least 3 men. And so we have our little chart here. Turn these guys into inequalities. Go to Desmos or graph them by hand, it doesn't really matter. And then get your corner points. Go back and figure out what you're trying to maximize here. We're trying to maximize the number of points. So, or the score, I guess I should say. Maximize score. So then we find out, well, what sentence tells us something about the score. Women score 4, men score 2, women score 4, men score 2. There's our equation that we need to maximize. This is our target function. And so then we just plug the numbers in and we find out that 5 women, 2 men maximize. Okay, so let's do the next problem, same way. It says Bob the builder is building, he's building tables and chairs. His shop can produce at most 12 pieces, so already we see a restriction there, of furniture. Customer demand indicates that he should produce at least 4 chairs. Another restriction, he can't make as many chairs as he wants, he's got to make at least 4. And 2 tables, same thing there. He makes $30 in profit for each chair, $50 for each table. That's going to be our function at the end, right? How many chairs and tables should Bob make to maximize his profit? And then I write here, only a solution that includes inequalities, a graph, and an optimization equation will be accepted. So just so you're not just like randomly guessing here. Okay, so we're going to make our chart here, and that's the most important part of this whole process here, making the chart. And we remember the story, Bob's making tables and chairs. And so I think tables was listed first. 4 chairs and 2 tables. Good, so we'll do that first. So chairs, tables, and that's an X, and that's a Y. And it says here that his shop can produce at most 12 pieces of furniture. So production. I'm going to call that production. I mean, it doesn't really matter what you call these things, just as long as you call them something. And we know that he can't produce any more than 12 pieces of furniture. And we also read that he needs to produce at least 4 chairs. Again, we can't make as many chairs as we want. We've got to make that many. And we got to make that many tables. So again, the restriction over here is the number of chairs and the number of tables. I have no idea why I just wrote that entire word out. So we're going to finish up our table here. And so we know he's producing chairs and tables, and he can only make 12 of them. So really, the number of chairs plus the number of tables has to be less than or equal to 12. And it says that the number of chairs has to be at least 4. And the number of tables has to be at least 2. And then, so that's the number of chairs. That's the number of tables. And we have our inequalities all ready to roll here. X plus y is less than or equal to 12. X is greater than or equal to 4. And y is greater than or equal to 2. And again, you're just going to flip these around. These guys here, 1, 2, 3. Flip them all around in decimals, and you're going to get this cool triangle. And as a matter of fact, again, as you might imagine, I have already graphed it for us, and there it is. So we get our nice points here, 4, 8, 4, 2, 10, 2. 4, 8, 4, 2, and 10, 2. 4, 8, 4, 2, 10, 2. Okay, so I wrote those down, and we need to have our little profit equation in this case. So it says here that he makes $30 in profit for each chair, $50 for each table. So our profit is going to be $30 times the number of chairs plus $50 times the number of tables. Then we're just going to, again, plug these into here and see what we get. So 30 times 4 is 120. 8 times 50 is 400, making 520. And 4 into here makes 120. 50 times 2 is 100, making 220. And lastly, 10 into here makes 300, plus 2 into there makes 100, so that's 400. So in order for Bob to maximize his profit of $520, he needs to must make 4 chairs and 8 tables. Now, as you might imagine, this whole problem might be just a nightmare if you just had to read this and try to figure it out without making some nice inequalities and a graph and a nice chart here. Definitely work the chart and the inequalities and the graph and go through the process here. It is so much easier. Trust me, I've done this many times. Okay. Lastly, I'm just going to do one more. Even though there are 4 here, we're just going to do one more. Okay. And we're already at the 16-minute mark. So it says Bob is taking a test. He thinks he can get at most 24 of the questions correct. Already we see a restriction. The directions say he has to do at least 6 problems from section 1. Another restriction. He can't do as many as he wants. He has to do at least 6. And 8 problems from section 2. Same thing. He will score 5 points for each question in section 1, 6 for each one in section 2. How many questions in each section should he answer in order to maximize his score? Okay, so we're trying to maximize score, and we need to know how many questions of each type to do, or each section. So we got section 1 and we got section 2, and again, cleverly, we'll call them X and Y, and we have the total number of questions, which we find out is 24, so at most 24. And he's got to do a certain number in section 1. Again, these are the restrictions over here. So what is it that prevents Bob from doing as many problems as he wants to on the test or in each section? So this is what it is. Total number of questions on the test, or that he thinks he can get. Number in section 1 and the number that he has to do in section 2. So these are the restrictions. This is what he's trying to find out. And now we just fill in the chart. And those of you who want to just, work ahead of me, that's great. You can even pause the video right now and finish out the problem. Okay, so we're already accustomed to this. Now, the total situation is always going to be this whole x plus y thing. So x plus y is less than or equal to 24. And then in section 1, he has to do at least 6 problems. So section 1, the number in section 1 is x, at least 6 problems. And, oh, nope. Yes, he has to do at least 6 problems from section 1 and, oh, that's 8 problems. Okay, good, yeah. Good, and 8 problems in section 2. And so we have x plus y is less than or equal to 24. X is greater than or equal to 6. Y is greater than or equal to 8. And again, graph those in Desmos by flipping these guys around, or graph them as they are, in Desmos, or graph them by hand. Either way, it's all good. And again, as you might imagine, I already graphed these for you. So we got 8, 16, 8, 8, and 16, 8. So we got 8, 8, 8, 16, and 16, 8. And now, okay, and now for the scoring. He will score 5 points for each question in section 1, 6 points for each question in section 2. So the total number of points is going to be 5 times the number in section 1 plus 6 times the number in section 2, and there we have it. So just plug 8, 8 into here. Should probably put parentheses around, make these ordered pairs. 8, 8 into here, so that's 40 plus 48 makes 88. That's 40 plus 48. And we do 8 and 16. So 5 times 8 is 40. 16 times 6 is 9, plus 96 makes 136. And then we plug 16 into here. So 16 times 5 is 80. Plus 48 is 128. So in order for Bob to maximize his score, he'll get 136. He needs to do 8 in section 1, 16 in section 2. Oops, that wasn't very good. Well, you know what I'm saying. There you go, 2. Okay, there you have it. So I'll give you 4 of these to do, very similar to these, and then we'll move up to bigger and badder problems like this for the next video. So anyway, hopefully you enjoy this. You got plenty of days to do this, and please remember to stay safe. See you on Monday.